Hello and welcome back to Calc 3. This is the part 1 of the lesson on triple integrals and cylindrical and spherical coordinates. So tonight we'll only probably look at cylindrical coordinates. But it's important to understand that both of these in the base have polar coordinates, and then we upgrade into the new coordinates that we need. So we know that the polar coordinates start with polar coordinates are 2D, and we have as r theta. So now the upgrade will be r theta z. So you take the polar coordinate circle you have and you straight up bring z, which are these planes, z equals 0 for the floor and z equals, let's say, 10 for the ceiling. So this is z equals a and z equals b, let's say, and you can see clearly that we are getting cylinders in that case. Or you can go rho theta phi. Now we change r to rho, why I don't know. And we are getting a sphere in this case because our good old polar coordinates are here, and then we are introducing another angle that will draw the curves on the sides. So these are called cylindrical coordinates, and these are called spherical. So we will first address, tonight we are only going to address cylindrical. So to address cylindrical coordinates, we are starting again by understanding the cylindrical coordinates r theta z. We look at the cylinder. We see that we have r and theta operating in the base, and then we have the height z. To convert between the two worlds, we are using the same conversion that we use in the polar. So x is equal to r cosine theta, y is equal to r sine theta, and z equals z. So that's one set to convert from polar into Cartesian, and then from cylindrical into Cartesian. And then we also have that r is equal to square root of x squared plus y squared. Theta is equal to inverse tangent of y over x, and z equals z, which is the conversion the other way. Now we are going to understand that these coordinates are not in competition with rectangular. These are there to supplement and simplify certain situations for us to integrate easier. So how does this work? Well, for our integral for volume, we are going to have a triple integral, and we are going to remember that we must have r dr d theta as a string. Oops, sorry, too close. You're using pens? Too bad. R dr d theta. And boom, dz. Now, this dz can go anywhere, but generally we like to integrate dz first because the top and the bottom of the cylinder doesn't have to be the flat plane z equals 10 or z equals 0. It could be half a sphere, in which case it's the equation that contains, right, r and theta in it. So dz could be simple, just numbers, in which case it can be anywhere in the integral, but most of the time it's not, which is the reason why we like to integrate dz first and then deal with the rest. So now I'm going to write out the entire integral. So that we know. I'm not sure what happened here. I lost the thing. Let me just a second. So with these integrals we compute the volume, but then we can also compute the 4D if we put the function inside. So let's go with the triple integral over region D of some function f of x, y, z dv can be computed using the triple integral So now, first of all, we have to convert. So f x, we know it's given as r cosine theta, y is given as r sine theta, and z is given as z. And then we have dz, r, dr, d theta. Remember that r dr d theta is the string from polar. That r is usually a killer for the grade. You forget it. Don't forget it. For the d theta, we have our alpha and beta limits. Those are the angles. The inner function g of theta and h of theta that deal with dr. And now dz is the function of x and a y, but they have to be converted again. So g of x, which is r cosine theta, r sine theta, and capital H, r cosine theta, r sine theta. Guys, do you want a cool tattoo? There you go. And then you learn this very well, so every time someone asks you what it is, you can sit there for 2 hours and explain. Now, this looks terrible when you look at it this way. Absolutely terrible. Let's use it. Let's find the volume of a circular, paraboloid. The simplest possible thing we can master, and then we'll go from there. So, say you have a paraboloid. Say this is 9, And the equation for this puppy is what? Z equals 9 minus x squared minus y squared. That's the equation. What's the volume? So what do I do? First order of business is I understand that the bottom is z equals 0. I have the shape for the sides. And I'm already ready to set up the integral. Volume is the triple integral. I'm not using any functions here because I'm just looking for the volume. I know that this string is dz r dr d theta. Don't forget this r. Now, d theta, I want the entire thing, and it's not a wedge, right? It's the entire round part, so 0 to 2 pi. The radius stretches from the origin to the edge, so we'll have to figure that one out. We know it starts from 0 because it doesn't have a hole. If it had a hole inside, then it would go from value 2 to something. We'll figure this one out later. And z is easy because the bottom is 0. It's the flat laying on the ground. And the top is the equation 9 minus x squared minus y squared. Now we also have to convert this, so we'll get there. We're still missing the r over here. Well, the first order of business is for me to convert this z into 9 minus r squared. Do you guys see that? Right? You have minus x squared minus y squared. If you factor out minus in front, you have x squared plus y squared. Now we know that's r squared, right? In a conversion. So you have 9 minus r squared. This is the equation in cylindrical coordinates, and this is the same equation in rectangular coordinates. So that's the same equation. It's the same equation, and it is that equation that I have to put here. Because I am not allowed to have any x's and y's in this integral floating about. Everything has to be in terms of r and theta and z because that is what I'm integrating in respect to. There are no x's or y's. And now the last part is to figure out what is the value that goes for the question mark. So for the question mark, right, it's going to be what is happening with the r, and what is the radius? It's 3. Yep. Because you are looking for the radius at the bottom, and it stretches from the origin to the edge. Now, that is happening on the floor where z is equal to 0. So plugging in z is equal to 0 gives me 9 minus r squared equals to 0, which is r squared is equal to 9. R equals to plus minus 3. Right, so it's 3. It's extremely easy integral to solve because we have, this is really quick. We have the integral 0 to 2 pi, integral 0 to 3, and when I integrate dz, I just get z, which is 9 minus r squared, r dr d theta. So now integrate, well, distribute, so 0 to 2 pi, 0 to 3, 9r minus r cubed, dr d theta, and now integrate. It's 9/2 r squared minus 1/4 r to the 4th from 0 to 3 d theta. 0 to 2 pi. Plug in 3. That's 981 over 2 minus 81 over 4. So that's all together 81 over 4. That's a constant, kick outside. And then integrate d theta, that's a theta, that's 2 pi minus 0. So 81 pi over 2. That will be the volume. Yeah, good luck integrating it in rectangular coordinates. It's not gonna work very well. Maybe you can pull it off somehow using the trigonometric substitution, but it will take very long time and be very tedious to solve this problem using rectangular coordinates. So let's see. Another problem. I like this one. So I'm going to set up my axis x and a y, and z. So what I have here is half of a cylinder. The top is, let's say, z equals 6. The bottom is z equals 0, sits on the ground. And let's say then these sides here go all the way to 4, which means -4 of the negative x-axis. What's the volume? Well, first of all, this is a middle school question, right? Because you have half of the soda can cut this way. So just figure out what is the volume of the whole can and just cut it in half. It's very simple. You know that the radius is 2, you know the height is 6, so base times the height, it's gonna be 16 pi times 6, right? 16 pi times 6. What's that, 96, right? 96 pi?
Shouldn't radius be 4 in this case?
Yeah, radius is 4. 4 squared, right? 16 pi for the area of the base. And then you cut that in half. So it's actually very easy to do this. Volume would be 1/2 of the base times the height, which is 1/2 4 squared pi times 6. 16, that's 8, 48 pi. So we have to get 48 pi using the integral now. Right? Using the sledgehammer when you don't need to, always fun. I see you don't have much experience with that, but trust me. One of the best things I've ever did was when I worked as you do odd jobs. So I went to this this company was moving out, and my job was, they gave me the sledgehammer and they say, you see those offices there? We don't need them anymore. I did not take payment that day. I didn't need the money.
Now, where would one go about finding such a job?
I guess I got lucky. Sledgehammer, and they just said, we don't need those offices anymore. Ah, yes. Anyway. And now I do this. So the Z, R, dr, d theta. Z clearly goes from 0 to 6. And what's happening with d theta? Zero to pi. So as you calculate this carefully, 48 pi. I'm really good with this, so. Six R, there will be 3R squared, 16 times 3, 48, and there's a pi. Yep. You can actually calculate the whole thing in your head. Hopefully. So let's see, as the grand finale over here. This is problem from the textbook, 31. They have this shape suspended in space. That's square root of 29. And the bottom is given as z equals the square root of 4 plus x squared plus y squared. What's the volume?
What's the root 29 represent?
Root 29 is where the flat is the ceiling.
The top is also the function of plane. Z equals
that's right.
The equation of the ceiling here is Z equals plane. It's a plane, it's a surface, right?
Okay.
This is Z equals 3.
No, set Z equals 0. Because that Z equation can form from. What a Z equation is, it's just root 4 plus R. Yeah. So then if you set 4 plus R first. No. Did it fall? Oh, I guess it was.
Yeah, this XC power person. What's x squared? What's y squared? Oh wait, would it be? Yeah. It would be. Shut up. Hey, what's up? Did you take all of that from a picture or not? No, we're still waiting on the test report. I'm talking with the president. I know, but like, I guess every priority right now is test report, and then, hey. I just got another email, someone was asking about the password. Oh, I mean, a while ago I was texting him, and he basically said, what did he say? I don't know, but like, he basically said, saying like about coding it with testing, but that didn't really make a lot of sense. Then he stopped responding to that one. Yeah, so the last message I sent was May 9th, and he read it at 4:10 p.m.
Did you say May 9th?
Yeah, May 9th.
Why would message him?
Yeah. Edwin, answer me. No, that's me. I'll talk to him next time I see him, but like I don't know when that is because the test report. So I didn't come back. Yeah, maybe. Maybe he's been up before. No, because the first I'm still in the group chat. Like Trevor just said, really, yeah, I was good. Maybe I'm like, yeah, sure, good. I was like, that's the shit. That's the bullshit. Being fun.
Maybe he's ignored me.
We ordered that like a month ago. Probably like 3 months ago.
Yeah, even if the shipping from China takes like 2 weeks. So we did order some drone parts, takes 2 weeks. And LEDs for the previous project, like 3-4 years ago, never more than 2 weeks. Anywhere from like week Why to are you
2 weeks.
ordering from China?
I think the place that we're getting from is American. Yeah, why even ask that?
I don't know.
It's called budget.
I'm a dummy.
I'll talk to him next time I see him about it.
All right. 1 minute, 20 seconds. Let's work this one out. And disappear into the night. So the volume will be computed as a triple integral. Since we are dealing with the volume, I'm not going to use any functions in here. So we hit immediately dz, r, dr, d theta. We are using 0 to 2 pi because it's entire thing. The radius will now stretch on top from 0 to wherever these guys meet. So 4 plus x squared plus y squared is equal to square root of 29, which is, when you square both sides, 4 plus x squared plus y squared equals to 29, which is x squared plus y squared equals to 25, so 5. The least it can be is 0, the most it can be is 5. Are we okay with that? And now, what is the other way to do this? Shine the light on top, it gives you the shadow right on the domain. That's another thing, the other way you can think about it. And then the z clearly goes, the bottom is the function, which is 4 plus r squared. Hopefully you already have PhD in that. X squared plus y squared is r squared. And then the top is just root 29. And this is just integrating now. You'll have one u substitution. Nothing, no problems here, right? Right? Right. Good. So I will see you all tomorrow. We will continue this lecture part 2 with spherical coordinates.